Good day, learners! Welcome back to Edwarriors Vlog Tutorials. In the previous episode of our vlog tutorial, we were able to discuss about factoring greatest common monomial factor. And for today's episode, we will discuss about factoring difference of two squares. In this lesson, you will see how easy it is to factor certain polynomials when you are familiar with the special products. In order to apply the correct pattern or formula, you must be able to identify correctly the special product involved. Before we proceed with our discussion, I'll present first the objectives. Number 1. Identify terms that are perfect squares. Number 2. Distinguish polynomials that are difference of two squares. Number 3. Factor the difference of two squares. Are you ready? Now let's begin. Consider the area of the following squares. Remember the formula in finding the area of a square? Correct. A is equal to s squared, where s stands for the side. This is a 2 by 2 square. So we have A is equal to 2 squared. And remember that 2 squared can be expressed as 2 times 2. So we have A is equal to 2 times 2. And now the area of this square is 4. Consider the second square. What do you think is the area of the second square? Again, the formula is A is equal to s squared. And if you have observed that the side of the square is 3, so we have A is equal to 3 squared. 3 times 3, and the area is equal to 9. Now let's have the third square. Again, area is equal to s squared. And notice that the side of this square is 4. So we have A is equal to 4 squared, and that is expressed as 4 times 4, and the area is equal to 16. Notice that 4, 9, 16 are perfect squares. Also, 36 is a perfect square because it can be expressed as the square of 6. 81 is a perfect square because it is a square of 9. X squared is also a perfect square because it is also expressed as the square of x. And lastly, 25x squared is also a perfect square because it can be expressed as the square of 5x. All of these numbers are perfect squares. Now let us compare the two ideas: squaring a number and finding the square roots of a number. Let's begin. 36 is a perfect square because the square root of 36 is 6. 81 is a perfect square because the square root of 81 is 9. X squared is a perfect square because the square root of x squared is x. And 25x squared is a perfect square because the square root of 25x squared is 5x. Now you already have learned about squaring a number and finding the square roots of a number. Now, let's apply the two concepts in factoring the difference of two squares. What are the dimensions of a square whose area is x squared minus 4? Using the algebra tiles, we have x squared, negative x squared, x, negative x, 1, negative 1. Is x squared a perfect square? Yes, you're right. How about 4? Is this a perfect square? Correct. Now, let's begin finding the factors of the given difference of two squares. We have here x squared minus 4. Remember that x squared is the result when we multiply positive x and positive x. Negative 4 is the result when we multiply positive 2 and the negative 2. Consider this is negative 2x, which is the result of multiplying a negative 2 and a positive x. This is positive 2x, which is the result of multiplying positive 2 and the positive x. Notice that this is our given x squared minus 4, and to get the factors of x squared minus 4, we have here x minus 2 and x plus 2. Therefore, the factors are x minus 2 and x plus 2. To check our answer, we will use the FOIL method, or the process of finding the product of the sum and difference of two terms. Now, x times x is x squared. X times 2 is 2x. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. Then combine like terms. Positive 2x and negative 2x can be eliminated, and that would result to 0. So we only have x squared minus 4, which is the given difference of two squares. Meaning, we got the correct answer. Now, what have you observed with the product and the factors? Have you observed that x and 2 are the square roots of x squared and 4, respectively? Have you observed that the sign of the factors are both positive and negative? Or the sign of the factors are both negative and the positive? So, to factor a difference of two squares, write the product of the sum and difference of the two quantities being squared. Is everything clear about finding the factors of the difference of two squares? Now, let us consider these steps. Step 1. Get the square root of the first term. Step 2. Get the square root of the second term. And step 3. Write the roots as a sum and difference of two terms. Are you ready to answer the given examples? Okay, let's try the examples found in your module. For number 1, we have x squared minus 9. Since x squared is a perfect square, and 9 is also a perfect square, and our symbol is the symbol for subtraction, then x squared minus 9 is a difference of two squares. Now, we can apply the given steps. Step 1. Find the square root of the first term. Our first term is x squared, so the square root of x squared is x. To check, x times x is x squared. Step 2. Find the square root of the second term. And the square root of 9 is 3, because 3 times 3 is 9. And last step, write the roots as the sum or difference of two terms. So we have x plus 3 times x minus 3. Or it can also be expressed as x minus 3 times x plus 3. This is by commutative property of multiplication. Number 2, 16a to the power of 6 minus 25b squared. Find the square root of the first term. So the square root of 16a to the power of 6 is 4a cubed, because 4a cubed times 4a cubed is 16a to the power of 6. Second, find the square root of the second term. The square root of 25b squared is 5b, because 5b times 5b is 25b squared. Lastly, write the roots as the sum and difference of two terms. Therefore, the factors are 4a cubed plus 5b and 4a cubed minus 5b, or 4a cubed minus 5b times 4a cubed plus 5b by commutative property of multiplication. Next, we have example number 3. A squared b to the power of 4 minus 81. So, let's begin. The square root of a squared b to the power of 4 is ab squared, because ab squared times ab squared is a squared b to the power of 4. Next, the square root of 81 is 9, because 9 times 9 is 81. Lastly, write the roots as the sum and difference of two terms. So we have ab squared plus 9 times ab squared minus 9 as the factors. Or, by commutative property of multiplication, this is ab squared minus 9 times ab squared plus 9. To check our answer, always perform the FOIL method, or the product of the sum and difference of two terms. And that ends our session today. I hope you have learned a lot in the discussion. See you in the next episode. Thank you for watching. Bye-bye.
Edward Marie. Hi, Edward Marie. Dapat.